Okay, let's look at another example of nodal analysis. So whoa, hey, that's not it. All right. Here is an example, a problem that we're going to work on next. Now, what's interesting about this particular problem is that, well, first of all, it has a power supply right over there, but we've learned how to handle that. But notice we have this power supply out here. So this power supply is not from a node to ground, it's between two nodes. So we'll need to come up with a plan on how to work that. So here's what I did. I have redrawn this up here. So you don't have to watch me do that. It's already done. And I drew it bigger. Let's add voltages and let's add the currents. So notice that we do have a 20 volt supply. So I know the voltage at this node is going to be 20, so I just wrote 20 volts right there. Here we have voltage 1 at node 1. Here I have voltage 2 at node 2. And at node 3 I have voltage 3. And I have assigned ground to this bottom node, which makes everything along this bottom 0 volts. So there's my voltages. Currents. See. And once again, the directions are I arbitrarily chose. You might choose them differently, but you'll get the same answers when you're done. All right, so I have current 1, current from right to left in this 20 ohm resistor. I have current 2 right here, which is the current from top to bottom through this 20 ohm resistor. Current 3 is right here. That is the current from top to bottom through this 10 ohm resistor. Current 4 is the current from left to right through the 5 ohm resistor right here. We know we have 9 amps coming up, so I just wrote 9 amps right there. And we have current 5, which is the current from top to bottom going through this 10 ohm resistor off to the side. All right, so there's my currents. I1, I2, I3, I4, and I5. Now what's interesting is we do not know the current through this power supply. We know it's providing 10 volts, but it can provide any current that's required to keep 10 volts there. So we don't know what that is right now. So if I want to write the Kirchhoff's current law, current in equals current out, I can't write it for node 1 because I don't know this current. I can't write it for node 2 because I don't know the current from here. So what I'm going to do is I'm going to make a supernode. Great name, isn't it? Supernode. So I'm drawing a little dashed line all around nodes 1 and node 2, and I can say the current into this supernode is equal to the current out of the supernode, because once again this power supply is not creating or destroying any charge, it's just pumping it, right? It's sucking charge in this side and it's squirting it out that side. So we don't know what the current is, but we know there's going to be some there. Nonetheless, for the supernode, current in equals current out. So I'm going to come down here, write the Kirchhoff's current law for SN, supernode. Current into this, 1 is out, 2 is out, 3 is out, 4 is out. Okay, so there's no currents in, so we have 0 is equal to current 1 plus current 2 plus current 3 plus current 4. So this equation right here is Kirchhoff's current law for the supernode. I can go to node 3 right here and write the Kirchhoff's current law. So I go look at node 3 and I have I4 coming in, 9 coming in. So there's current in is I4 plus I9. Current going out is I5. So there's my current out, I5. So this is the Kirchhoff's current law for node 3. Now I need, for these currents, I need Ohm's law, an Ohm's law version of them. Once again, for any resistor, current is the voltage drop across the resistor divided by the resistance. So for I1, we have, what's the voltage here? V1 minus 20, that's the voltage drop across this 20 ohm resistor. V1 minus 20 over the value of the resistance, 20 ohms. For I2, we need an equation for I2. It is through this 20 ohm resistor. Voltage across that is V1 minus 0. And the value of the resistance is 20 ohms. It goes on the bottom. Same thing for I3, the voltage across it is V2 minus 0. The resistance is 10, so we have V2 minus 0 over 10. For I4, the voltage for the current in that direction, it is the voltage at the left minus the voltage at the right, or V2 minus V3 divided by the 5 ohm resistance. So I4 is V2 minus V3 over 5. Finally, I5 is going to be V3 minus 0 divided by the value of the resistance, which is 10 ohms. Alright, so there's my Ohm's law for I1 through I5. I just take those guys and I plug them in over here. So I plug this equation right here for I1, this equation right here for I2, this equation right here for I3, and here's what we end up. 0, V1 minus 20 over 20, plus V1 over 20, plus V2 over 10, plus V2 minus V3 over 5, just from plugging these equations into those terms. Same thing for node 3. I4 is V2 minus V3 over 5, so I put it right there. 9 is still 9. I5, V3 minus 0, 10, so I plug it right there. Alright, so I have 2 equations, and 1, 2, 3, 4, let's see. I have 2 equations and 3 unknowns. Alright, that's no good. We can't solve that. But if I go look at my supernode, I notice there's a relationship between the voltage at 1 and the voltage at 2. Whatever the voltage is at 1, 10 volts gets added to it and we have V2. So V2 is V1 plus 10. V2 is V1 plus 10. I can just tell that by looking. So there we go. We have 1, 2, 3 equations in 3 unknowns. We're done with the circuit analysis part. Now there's just a whole bunch of algebra to get us to the solution. Let's go look at that. I'm not going to show you all the details, but I take these 3 equations, put them in standard form, and I get 1, 2, 3 equations here. Put those into a matrix form. It looks like this. I either plug them into my calculator or MATLAB, and we get the solution, which looks like that. All right, there we go. Hope this has been useful.